This video demonstrates how to use the FAIRINO as a Modbus TCP master. First, let's go to the coding section and create a new program. Open the Modbus TCP settings interface. Select Master Settings and add a master station. The robot supports up to 8 Modbus TCP masters communicating with external devices simultaneously. Each master supports up to 128 registers. Each register can be assigned a unique name based on its function to distinguish between them. Before using FAIRINO as a Modbus TCP master to communicate with your device, please check the network connection between your device and the robot first, and verify that the network interfaces are on the same subnet. Based on your device configuration, enter the following in order: name, slave IP, port number, slave station number, communication cycle, and overtime time. As the master station, the robot needs to connect to external slave devices. In this video, Modbus slave software is used for simulation. Open the Modbus slave, click Connection, and select Modbus TCP IP. Select the IP address of the computer's Ethernet port. Return to the robot's Modbus TCP settings screen and configure the master station information. For master station registers, configure the DI and DO registers and change their address numbers to 1, 2, 3, and 4, respectively. Modify the corresponding register names accordingly. A flashing green light on the connection status indicates that the data types of the slave and the master do not match. First, demonstrate the DI and DO read operations. Select the Modbus command, then select the master station. Select the digital output. Select register _3. Set the number of registers to 2, and set the register values to 11. Click Write and Add. Select digital input. Choose register _1 for the D name. Enter 2 for the number of registers. Then click Add and Apply. Assign the read DI value to variables A and B. Save the program after adding the query variable statement. Select MB slave 1. Click Setup. Slave definition. Set the slave ID to 1. Select function code 1. Set quantity to 20 and click OK. Create a new MB slave 2. Select function code 2. Set the quantity to 20 and click OK. Set the addresses 1 and 2 of the MB slave to 2 on. Return to the robot interface the address values for DI1 and DI2 are 1. Run the program. The address values of DO1 and DO2 become 1. In the robot printing interface, variables A and B are displayed as 1. Next, we will demonstrate read and write operations for unsigned AI and AO. Add to AI unsigned and AO unsigned. Set the address numbers to 5, 6, 7, and 8, respectively. Modify register names. Select the Modbus communication protocol. Select the main station, then select analog output. Select register _7. Enter 2 for the number of registers. Enter 11 and 12 for the register values, then click Add. Choose the analog input. Select register _5. Enter 2 for the number of registers, then click Add and Apply. Assign the read AI value to variables A and B. Save the program after adding the query variable statement. Select MB slave 1. Set the function code to 03. Set the quantity to 20. Click OK. Select MB slave 2. Set the function code to 04 and the quantity to 20. Click OK. Set the addresses 5 and 6 of the MB slave to 13 and 14. Return to the robot interface. The values for AI5 and AI6 are 13 and 14. Run the program. The values at addresses A07, A08 change to 11 and 12. The addresses for MB slave 1, 7, and 8 also change to 11 and 12. In the robot printing interface, variables A and B are displayed as 13 and 14. Next, we will demonstrate read operations for the symbols AI and AO. Add to AI signed and AO signed. Set the address numbers to 9, 10, 11, and 12, respectively. Change the names of each register. Select the Modbus command. Select the master station. Select analog output. Select register _11. Set the number of registers to 2. Set the register values to -21 and -22. Then click Write and Add. Click Analog Input. select register _9, enter 2 for the number of registers, then click Add and Apply. Assign the read AI value to variables A and B. Save after adding the query variable directive. Select MB slave 1. Set the function code to 03 and the quantity to 20. Click OK. Select MB slave 2. Set the function code to 04 and the quantity to 20. Click OK. Set the addresses 9 and 10 of the MB slave 2 to -23 and -24. Return to the robot interface. The values at addresses AI9 and AI10 are -23 and -24. After running the program, the values at addresses A011 and A01 to change to -21 and -22. The values at addresses 11 and 12 of the MB slave 1 also change to -21, -22. In the robot's print interface, variables A and B are displayed as -23 and -24. Next, we will demonstrate write operations for floating point AI and AO, add to AI float and to AO float values, respectively. Please note, floating point registers occupy 2 addresses, and those addresses are even numbers. Set the address numbers to 12, 14, 16, and 18, respectively, and modify the register names accordingly. Click the Modbus command, select the master station, select the analog output, select register _16, set the number of registers to 1, and set the register value to 33.5, click write and add, select register _18, set the number of registers to 1, and set the register value to 34.5, click write and add, select analog input, select register _12, enter 2 for the number of registers, click add and apply. Assign the read AI value to variables A and B. Save after adding the query variable directive. Select MB slave 1. Set the function code to 03 and the quantity to 20. Click OK. Select MB slave 2. Set the function code to 04 and the quantity to 20. Click OK. Select all addresses in MB slave 1. Right-click and select Format, Float of CD. Perform the same operation on MB slave 2. Set the addresses 12 and 14 of the MB slave 2 to -35.5 and 36.5. Return to the robot interface. The values at addresses AI12 and AI14 are -35.5 and 36.5, respectively. Run the program. The values at addresses A016 and A018 change to 33.5 and 34.5. The addresses 16 and 18 for MB slave 1 also change to 33.5 and 34.5. In the robot's print interface, variables A and B are displayed as -35.5 and 36.5. Finally, the demonstration shows how to use the commands for waiting for digital input and waiting for analog input. Add a DI and an AI unsigned. Set the address numbers to 12 and 13, respectively, and modify the register names accordingly. Click the Modbus command, select the master station, select the waiting for digital input to be set setting, then select register _12, set the wait status to true, and set the timeout to 5000 milliseconds. Select the waiting for analog input settings, choose register _13 for the AI name, set the wait condition to greater than, set the register value to 1. Add the corresponding digital input and analog input instructions. Assign values to variables A and B. Save after adding the query variable directive. The program logic is to print the values of the variables if the conditions are met within 5 seconds. Otherwise, it will report an error and stop. Select MB slave 1. Set the function code to 02 and the quantity to 20. Click OK. Set address 12 to 1. Select MB slave 2. Set the function code to 04 and the quantity to 20. Click OK. Set address 13 to 2. Return to the robot interface. The values at addresses DI12 and DI13 are 1 and 2, respectively. Run the program and check the values of variables A and B. That concludes our overview of the FAIRINO robot as a Modbus TCP master. Thank you for watching.